Hi everyone, this is the first lesson in our second unit of geometry support. Our goal in this lesson will be to combine like terms and simplify expressions. So throwback, we also want to be able to talk about different parts of expressions, so we're going to focus on some definitions. All right, let's first think about these definitions. If I look at this expression here, we're going to first define that to be an expression. So an expression has a bunch of different parts. We want to give specific names to them so we can talk about them and refer to the individual pieces. The first part we're going to talk about are called the coefficients. So make a little note of that there. Coefficients will be the first part. And they are whichever pieces are attached to a variable. So I'm going to highlight my coefficients in yellow. One coefficient is 2. 2 is attached. It's being multiplied to the variable x. Right there. It's being multiplied to the variable x. So it's a coefficient. If you're having trouble remembering it, whenever I think of I think of cooperative or coordinated. Basically, it means together. So a coefficient is a number that's together with a variable. Another coefficient is positive 5. A third coefficient in this case is negative 4. And we had to keep the negative on there because it's really a negative 4 that's being multiplied by x. So I'll make note of those. Our coefficients are 2, 5, and negative 4. That's our first definition. The second definition is going to be variables. Variables. I'm going to highlight my variables in blue. One variable there is x. It's an unknown quantity. It's something that could be a bunch of different values based on what it needs to be for the problem. Y is another example of that. And obviously there's x showing up again later. So our variables in this case are just x and y. And again, we call them variables because they vary. They can change value. They could be 1, they could be 2, they could be a million, it could be negative 2, it could be anything. And then lastly, we'll have our constants. I'll do this in orange. I see there's only one constant. We call them constants because they don't change, right? The value here, 6, is a constant. Positive 6. 6 is fine. It's constant because it is the number 6. It doesn't change in quantity. It's not connected to a variable like a coefficient is. It's just a constant. And all those things together make up an expression. I'm going to also note that each of these could be called a term. In an expression, there are many terms. Each term could be a coefficient, could be a variable, could be a constant, but those terms together make up an expression. So those are just some vocab terms so that when I'm talking about an expression or a term or a coefficient, we'll have an idea of what I'm talking about. All right. Now that we know these definitions, we're going to talk about combining like terms. So first we have to decide what like is. Like in our language, in math, we're talking about terms that have the same variable or the same constant or the same sort of structure. So looking here, an example of two like terms, I have negative 2n and I have positive 3n. Those terms are like because they both have an n. They both have the same variable to the same power. They both just n's. They are unlike another set of terms is 5n squared. N squared is like negative n over here. Those two terms are like because they both are n squared. So the same type of thing. In this one here, there's 5n squareds. Over here, there's a negative n squared. So they are like terms because they're both n squareds. And then lastly, we have our constant, which is just 6. So now I'm going to write these, I want to combine them. We don't want to talk about having 5 of one thing and taking away 1. We just want to put it as one like term. So to combine them, I'm talking about these things, n squareds. Let's combine those first. Well, I have 5 of them on the left and negative 1 of them a negative. We could imagine there being a 1 here, a negative 1 over here. If I combine them, that's 5. I take away one of them, that leaves me with just 4. 5 take away 1 is just 4. So there's 4 n squareds. So we've taken care of the n squareds in our expression, and we've combined them into just one term. And I'm going to 4 n squared. I'm going to highlight that in orange so we can see the color. Next, we'll do n's. There's our next. I have negative 2 n's on the left and 3 n's on the right. So one way I could think about it, I could think of having 3 n's and take away 2 of them. If I have 3, take away 1, take away 2, that would leave me with just an n. A good way to do this without messing up our signs would be to make a number line. So I'm going to make a little number line over here. So there's 0 on my number line. I'll make space for negative 2, because that's a point we care about. Right. Now if I start at negative 2, that's my first term, negative 2 n's, I'm adding 3 n's onto it. So when I'm adding on the number line, my positive numbers are to the right, my negative numbers to the left. I want to move 3, positively 3, 1, 2, 3, to the right, and see that that takes me to 1. So that's just using a number line to help me identify what my terms will be when I combine them. Negative 2 plus 3 takes me to positive 1n. So plus 1n. I'm going to highlight that in yellow so we see where it came from. The last term, all that's left, I've taken care of everything but this constant, this plus 6. I can't combine it with anything because there's no other constants like it. So I'm just going to write plus 6 there and highlight it in blue. So altogether, we've simplified this expression to just be 4n squared plus, I could either write it as 1n or just n plus 6. Awesome. So there's an example of just combining terms. We picked out which are alike, put them together, and instead of having, 5 terms in total, we now just have 3. Simpler. All right. Next, this expression has 2 groups in it. I see this group over here to the left of 2x minus 5y, and I see a group over here to the right of 4x minus 3y plus 2. And in between them, we have this negative sign saying that we're subtracting these. So this is different than our expression above, because here it wasn't grouped at all. They just had terms with signs on them. Here they're grouped. And what this group is saying is that we need to subtract, so that minus sign means subtract, everything inside this group, all 3 of those things. So I need to subtract 4x. I need to subtract negative 3y, and I need to subtract 2. So when we're subtracting a group, I have to take each thing in that group and subtract it. What I like to do to simplify this so I don't mess up the signs is just rewrite it with the signs changed to subtraction. So 2x stays, 5y stays. We'll deal with them in a second. I'm subtracting 4x. So to represent that, instead of it being a 4x, I'm going to go minus 4x. So check, taking care of that one. Next, I'm subtracting a negative 3y. If I subtract a negative, that's the same as adding. Minus a negative 3y is the same as plus 3y. So whenever I subtract a negative, I want to add it. So instead of subtracting it, I add it. And then here, minus 2. So the only way that's easy to get tripped up in a case like this is if we don't forget to subtract every part. And what I love to do is just put the arrows down. Because if I have the arrows there, I'm not going to forget to subtract the 4x first, then subtract the negative 3y, then subtract the 2. 1, 2, 3. All 3 parts. Right. Now our problem looks almost a lot like the one we had above. I just have 5 terms laid out. Some of them are like, some of them are not, and I'm going to combine them. 2x is like 4x because they're both x terms. Negative 5y is like 3y because they're both y terms. And negative 2 is a constant. It's only one. All right. For the yellows, so the x's, 2 take away 4. Again, if I'm stuck, draw a number line. 1, 2. I'm just going to make some space on this number line because we'll use it for a couple things. All right, I'm at 2. 2. And I need to take away 4 x's. 2 minus 4x. So here we go. 2, take away 1, 2, 3, 4. That takes me down to negative 2. 1, negative 2. Yep. So overall, there are negative 2 x's. And maybe, if we're confused, I'm going to cross out those terms, showing that I'm done with them. All right, next I'm going to do the y's. I have negative 5y here, and I need to add 3 to it. Well, that's fine. I'm going to go over to my number line and go to negative 5. I'm going to add 3. Negative 4, plus 1, plus 2, plus 3. Plus 3 takes me right there. No, it also took me to negative 2. And if you have other ways to add and subtract negative numbers, that's great. But I just like this way because it's visual. So minus 2y's. That's blue. And then the constant, there's nothing else to combine. There's no other constants. There's nothing else like it. So I'm just going to leave it, negative 2. Great. So negative 2x minus 2y minus 2. So we took originally this problem up here, which had groups and a minus and 5 terms, and condensed it, made it simpler to just have 3 terms, one of each type. All right, so that pretty much does it. We want to be able to talk about expressions, including that they're made up of terms. Each term could have a variable which has coefficients attached to it, or it could be a constant. We also want to talk about like terms and how we can combine them to make our problems simpler. Okay. To practice these skills, the first part of the question just asks you to identify the coefficients, variables, and constants, so you might be able to split it up into a table like we did in the example. And then the second question on the back says circle the expressions, and I should be specific there. There's expressions. There are many that are like, that are equivalent to 3x minus x plus 5y minus 3. So here's an expression. If I'm looking at that, I think, ooh, I don't know